That's it. The linear relationship between voltage and current. What is Ohm's law? Will you repeat what is Ohm's law? What is Ohm's law? Will you repeat it for me? What is Ohm's law?
Electric current.
You didn't learn the definition of Ohm's law? Then how you will write an exam? See, we do our study to understand the things as well as to express ourselves to get marks as well. Okay. If you want get good marks, this is the situation or system. If you don't get good marks, then people will understand or make the notion that you don't know the things. You know the concept is good, but also you have to memorize you have to learn the definition as well. So you have to keep in mind the definition as well. Okay. So now tell me, what is Ohm's law? Suppose this is a metallic wire, okay, of length L. And it is maintained in a potential difference V. A current I is being flowed. So what will be the relation? Then potential drop will be directly proportional to the current induced. It is readable to you, the
Yes,
font size and all. Okay, so it is directly proportional to I. As we see that this voltage is being supplied by battery. Okay, so if we have to use the remote or TV remote, we have to use a small size battery, pin torch battery, right? In TV remote, a pin size battery. But when we have to learn the when we have to use the battery in car or electric vehicle, we need n number of 12-volt batteries, right?
yes.
So as we increase the battery with the potential difference, we increase the current. So the TV remote need a small current, but the battery in bus or car high current. So we increase the number of batteries. So it says that as we will increase the potential, the current will vary. So V is directly proportional to I, and then if we will remove that proportionality constant, then it will be R into I. So if we have already brought it like Y is equal to mx. So this is V and this is I. This is a straight line. Right?
Yes, sir.
So if this is the case with conductor. If we have conducting material, then we will get a straight line nature. That is also called ohmic material. OHMIC, ohmic material. Right?
Yes.
Some In the case of alloy or semiconductor, we won't get this nature. We may get different nature. So semiconductor is different from this ohmic nature and all. We may study in higher classes. Okay. In semiconductor or alloy, we won't get the straight line. So this may be the limitation somewhere. So how we will define the 1 ohm? Sorry,
One.
1 volt. How we will define the 1 volt? That there are some basic definitions that may be asked repeatedly in exams. So we know what is definition of Ohm's law. We must have to know what is the definition of 1 ohm. Okay, 1 ohm is that when unit current passes through a given circuit in unit time interval, right?
Sir.
I think we already discussed these concepts earlier.
Yes.
Okay, so keep in mind, are you making notes?
Yes, sir.
So you should be keeping all those things in mind. I'm waiting for few more students. They might be coming. They might be coming. Oh, we are already 9 minutes late. We 9 minutes past. So we did this numerical in the class, right? The numerical number 11.13.
Yes, sir.
Okay. I think we solved all 2-3 numericals. We also did this numerical in the class.
No, sir.
The potential difference between the terminal of electric heater is 160 volt. When it draws a current of 4 ampere from the source, what current will the heater draw? Potential difference is this much. We didn't?
No, sir.
So will you do it?
Yes, sir.
Okay, do. First of all, write down the data. Okay, then the potential difference between the terminal of electric heater, and write it B 60 volt, and current is 4 ampere. Then we will find the resistance over here. The one quantity that is missing is resistance. In the second part, it says the current. What current? Then current is being asked. Will the heater draw if the potential difference between them is 120 volt? From here, we will get resistance, and this resistance will be over here, and we will calculate the problem. Okay? Do it. Any progress?
Sir, the last one I'm doing, the second one.
Okay.
Done, sir.
Okay, so what's the answer for this?
15 ohm.
15 ohm, right. And what about this?
8 ampere.
V is equal to I R, then I is equal to V over R, right? Then
Yes.
V was 120 and this is 15. 8 times, right?
Yes.
8 amperes. 8 amperes. Okay, clear?
Yes, sir.
So did you try some question other than this on your own?
No, sir. Only
So
the
which,
assignment one.
okay, so which book do you follow? NCRT or some other books as well?
NCRT and one Oswald one.
Oswald books. Do you have soft copy of that?
No, have the textbook on.
Okay, Oswald textbook. Okay, okay. So your school used NCRT only?
Yes, sir. NCRT
Uh,
and NCRT example.
Okay, okay. So practice as much as question you can, okay?
Okay, sir.
Okay, now I think this is no. We will come back to this concept later. The next topic we have to learn is we learned that in Ohm's law there is two known quantities, okay? Potential difference and current. If we will change the battery size, the current will change, right?
Yes.
But we don't know how to fix the R. How the R will come into the picture, it is bit different from the size of battery or from the apparatus that is drawing the current. Our mobile charger draw fewer currents, fridge and refrigerator draws large amount of currents, right? That's somehow related with the given potential and the user supply. But we are little bit have to find what is R. So now we have to see that how R dependent resistance depends on the factor which the resistance of a conductor depends on. What are those factors which resistance can be depend? So first thing is R is directly proportional to the length of conductor. Length, length of conductor, right?
Yes.
As long as the length of conductor is, resistance will be high. Resistance will be changing. As we do the supply, that wire that's being transmission wire, the length, as the length increases, the due to the resistance, the potential drops at the other ends. If it starts from one part of the India and it goes from another to the another part, then there will be slightly difference in the potential drop because of resistance. So what another factor it depends on? It's inversely proportional to the area of cross section. Area of cross section, right? Directly proportional to length and inversely proportional to the cross section. Okay. Despite from this, it depends also on the temperature. How the resistance change with temperature, I will tell you in a moment, and the material. If we use wood, then it will be different case. If we use the copper wire, then resistance will be different. COOPR copper wire. In both of the case, the resistance will vary for the same amount of currents. So in nutshell, if we want to write these two statement, we will write it like R is proportional to L over A. L is the length of conductor and A is the area of cross section. What do we mean by area of cross section? See, if this is a thick wire, okay, so this is the, if you will cut it perpendicular to the edge, what will be the surface at the, see, this is the, this part, this is the part, oh, this is the blur, okay. This part, if we will cut it, this is the area of cross section, right?
Yes, sir.
And this is the area of cross section. So as the area of cross section will increase, resistance will decrease. Area of cross section increases, resistance will be decreasing. L will be increasing, resistance will be increasing. This is the direct proportionality and this is indirect proportionality. So now we have to remove the proportionality constant and see how it is behaves. It will be R, a new constant will come, rho L over A. What is rho? This is the proportionality constant called resistivity. It's resistivity. Yes, it's resistivity. Let me have a look. And this is resistivity. Rho is resistivity. Resistivity of material. Is visible?
Yes, sir.
Okay. So what will be the another case? R is the resistance. R is resistance. What about reciprocal of R will call conductance? CONDUC TNC conductance. Resistance is what? Is the amount. Resistance is what? Can you give me the definition?
So, which definition?
Resistance, definition of resistance. How we define the resistance?
That the capacity to hold the electricity.
Okay. And what about the conductance? Just opposite. The amount,
The amount of
yeah.
the amount
Allow.
of
Yes, go ahead.
the amount of current to hold.
Yes. This will allow. Conductance means the allow. And resistance means to stop. The amount of resistance is the measure how it obstructs the flow of current. And conductance is the amount of which allow the amount of current is being allowed to pass through a conductor. This is resistance and conductors is reciprocal of each other. Okay.
Okay, sir.
So you may write it down all these statement. These statement from here. This is the definitions. Okay. After this, you may write it till here. Finally, write R is equal to rho L over A. This will end this definition. Okay. See, you may don't write this line. Just start from here. Resistance is directly proportional to length of conductor. Area of cross section of conductor. Directly proportional length of conductor. Area of cross section of conductor. Resistivity is inversely proportional to cross sectional area of conductor. Resistance is directly proportional to this line. Resistance is directly proportional to length of conductor and inversely proportional to cross section area of conductor. So write it like that. Resistance is directly proportional to the length of conductor and inversely proportional to the cross-section area of conductor. Okay?
Okay, sir.
Okay, just write, make it short.
Done, sir.
Okay. So what this point? How the temperature with increase? My question is that with increase the temperature, as will increase the temperature, the resistance will increase or decrease. What's your experience? Can you tell me anything?
The resistance will increase.
Yes, of course. How this happens? See, let me. Can I remove this part?
Yes, sir.
Okay. So conductors are made up of n number of atoms, right?
Yes.
Each atom is like a point structure. You may say that when electrons will flow, it will make collision with each other.
Yes.
Suppose this is a conducting wire. So there are n number of atoms, right?
Yes.
So when we will heat, the thermal agitation will be over here. Okay.
Okay, sir.
Heating. Then what will these atoms and molecules will do? They will start vibrating. Okay. There will be vibrational motion. So now it will collide with each other. The collision will be more frequent. As the collision will be more frequent, the collision time will decrease. Collision, COLLISION, collision time will collision time T will decrease, right? As the collision time will decrease, what will happen? The flow of charge, the flow of electron will also decrease. So there is term called drift velocity. Velocity of electron under the influence of field or heating effect. So velocity will increase. The velocity will also decrease. Decrease. As the velocity of electron will decrease, the flow of current will decrease, right? So resistance will increase. If flow of velocity will increase, it means the flow of current will increase. So it means that resistance will decrease, but heating effect, the thermal vibration of molecules or atom will increase. In that response, the velocity will decrease. The velocity will decrease, then resistance will increase. Clear?
Yes.
Will you write it down in your own word?
Yes, sir.
Okay. So after this discussion, we will see how some materials help us to make our instruments more feasible. See, these are conductors. What are conductors? What are conductors? Conductors are those whose resistivity is less. 10 to the power minus 8 is almost 0. We can't say 0. Okay, 10 to the minus 8. 10 to the minus 8 is very small. But if we will see the insulator is 10 to the power 14 to 10 to the, it is visible to you?
Yes, sir.
So this is too much high, 10 to the power 16, 10 to the power 14. So it is too much high. But in a state of this C, alloy, 10 to the power 6 or something is in between. So conductors are those which allow current to pass it through without much resistance. That is conductors. Or conductors are those which allow current to pass through it. Insulator are those material will stop the current to flow through it, right?
Yes.
Alloys are the made up of two or more than two materials or conductors. So see, silver is 1.60. So all the expensive mobile phones or instrument in the surveillance securities, they are the wires of those components, instruments are made up of silver. Got the point?
Yes, sir.
And sorry?
Yes, sir.
Yeah. Or the cheaper things are being made up of iron, nickel, tungsten, aluminium. Our home supply, the current, the transmission line is made up of this aluminium, which has 2.63 10 to the 8 ohm meter of resistivity. Acha, one more thing. Okay, so we didn't discuss the unit of this row. Okay, so how we will do that? We will keep row one side. See, again I am writing is R is equal to rho L. Area will be L into L, right?
Yes.
So we will cross 1 into 1L. So here it will be rho will be R into L. This will be rho. R is ohm and L is meter. So this is ohm meter. Clear?
Yes, sir.
So this is the unit of resistivity, ohm meter. You may mention there where you have made the note.
Okay. Done, sir.
Okay. So see, as we come from up to down, we see that resistivity is increases. So resistivity is increases. It means that silver is a good material, but aluminum is less in sense of its utilization. Nickel is less than that. Okay. Mercury we use in our thermometer. See, it has 94.0 into 10 to the 8 resistivity. Resistivity and conductivity, keep in mind, these are two different terms. Remember all these alloys name. Okay. You may be asked frequently in exams that nichrome is made up of nickel, chromium, magnesium, and iron. Similarly, magnesium, copper, magnesium, and nickel. Manganese, manganese is different. Constant and nickel and copper. Similarly, tin is anywhere here. Tin is also an alloy, right? Tin is also an alloy. Similarly, in insulator, we say that resistivity is increased. Now it's 10 to the power 14. So it's tough to current to pass through these materials. Dry paper. It's written over here, dry paper. If the paper is wet, then there will be some H2O molecules, right?
Yes, sir.
So H2O molecules, when we will pass the current through it, you must have read in chemistry. It will allow the current to pass through it readily, right?
Yes, sir.
The salt water is good conductor of electricity.
Sir,
Distilled salted water, salt water, salt water.
sir,
Yeah,
sir, then why they are saying human body is a good conductor of electricity?
because we have blood in our blood cells. Okay, blood contains what? It contains water, some other material as well, right?
Yes, sir.
Some minerals. So all these conducts electricity.
Okay.
Got the point?
Yes, sir.
But our dry bones are not that much conduct. Dry bones are really insulator. If our skin is dry, okay, that's somehow you just toast the skin. If there is no water molecules in our skin, then it won't conduct electricity. The main factor that being used to conduct the electricity is H2O molecule. If you drain out all the H2O molecules, then it will be like insulator. Got the point?
Yes, sir.
Okay. So now move on to the next. Now it's a description of a table. That's upper table. You don't have to remember the all things, but you have to remember that only alloys. Okay. You might somewhere ask in the exams. The resistivity of alloy is generally higher than that of its constituent metals. Alloy do not oxidize or burn readily in high temperature. For this reason, they are commonly used in electric heating devices like electric iron, toaster, etc. Tungsten is used almost exclusively for filaments of electric bulbs. So this is the use of one of the alloy, that is tungsten. Okay. The electric bulbs are made up of tungsten. Yeah. Tungstens, electric bulb. Not that's a neon bulb, neon bulb or filament bulb. are made up of tungsten. Tungsten. Okay. You must have seen the filament bulb back in your village,
Yes.
right?
Yes, sir.
Whereas copper and aluminum are generally used in electric transmission lines. That's also you have seen in our village across in India. But we don't use copper nowadays because copper is being theft. Okay. So that's why copper is not being, but aluminum is generally used. Clear?
Yes, sir.
It's clear. Then have you noted down?
Yes, sir.
Okay. So now we have this small activity. Should we do this or leave it?
If it's important, we can.
It's only just for some experimental setup. Okay.
Okay, sir.
What we studied in one case is saying that we have to use a wire of length L of the thickness. Okay, that's saying replace the nichrome wire of thickness L and see how the resistance behave. So R is already, we know R is equal to rho L over A. In the second case is saying that in the first case, this is this. In the second case is saying that L will be 2L, how the resistance will change. In the third case, this is the second case. Third case is that now area prime is twice the upper area, earlier area, the area A naught. The A prime is the new one or A is the old one. Okay.
Okay,
So
sir.
how the resistance will be changing? You have to set up an experiment and do it. Okay.
Okay.
In the lab, you may be doing it. Clear?
Yes, sir.
Do you perform lab over there?
No, sir.
No lab?
No lab.
Oh my gosh.
Lab
They say,
practicals are there, but no lab experiments.
oh my gosh, it's the same in India. Okay, so now we have this problem. 1.16, sorry, 11.6. Will you able to do it?
Yes, sir.
Is visible to your size?
Yes, sir. Can you please explain that equation?
Okay. I'm dividing it in two parts. Okay. A wire of given material of length L. Okay, this is length L of cross-sectional area. Cross-sectional area A. Okay, has resistance 4 ohm. R is rho L over A. So resistance is 4 ohm. This will be equal to rho L over A, right?
Yes, sir.
Clear?
Yes,
Now,
sir.
what would be the resistance of another wire of the same material of length L by 2? Now, length is L by 2. Okay, this may be the L final, L prime. This is L by 2. Okay. And area of cross section, this is twice A. Area of cross section is twice A. Okay. So this is 2A. A prime is 2A. So what is being asked? What would the resistance? Question clear?
Yes, sir.
Can you proceed?
Sir, can you do it?
Okay, no problem. Then R prime will be what? Rho L prime or A prime. Rho will be the same. Okay, we don't have to worry about the rho. So what is this? The R prime, sorry, L prime is L by 2 rho. This is L by 2, right?
Yes.
And what is A prime? This is 2A, right?
Yes.
So what we will be writing it, R prime is equal to rho, or this will be 1 by 4, 1 by 2, 1, 2, 4 and L1A, right?
Yes.
This is the thing. The calculation is clear?
Yes, sir.
No doubt.
Yes.
So this will be 1 by 4 rho L over A is nothing but this quantity, right?
Yes, sir.
And its value is 4 ohm. 1 over 4 into 4. R prime will be 1 ohm, right?
Yes, sir.
Cancel. So this will be 1 ohm. Clear?
Yes, sir.
So I think the next time we will study the resistance of system of resistors, right?
Yes, sir.
So any confusion or any doubts regarding today's class?
No, sir.
Everything is okay?
Yes, sir.
Okay, no problem. So still we have 5 or 10 minutes. Still we have 10 minutes to go. So what do you mean by circuit diagram? What do you mean by circuit diagram? Are you there?
Yes, sir.
What do you mean by circuit diagram?
To represent the symbols of electric.
Okay. Not only to represent the symbols, to represent any electrical circuit using standard symbols. The circuit diagram is the working diagrams. Okay. If we have to draw a diagram for mobile phones or something, you must have seen the chip. Okay.
Yes.
And there are n number of craving like this, so it's hardly to understand. But these are the working things. Okay. And with the given symbols. The circuit diagrams are the real electric circuit, but just to understand it, it's not the same one. So just to understand it, we make each and every details specific. Okay, if there is some plug sign, so it will be there a plug sign. And if it has positive and negative, so we have to, for example, we have to keep it positive. If you will see the charger, mobile charger, there will be n number of dots, right?
Yes.
N number of dots. That's the front view, na? So in each, there will be symbol. If you will open it, there will be symbol written, some positive, negative, positive, negative, positive, negative. This type of singles. So it is the, if anyone who knows the electronics little bit will see and understand, okay, these are the meaning of these components. So these are the practical and practical working circuits with given standard symbols, right?
Yes, sir.
So what is work done in bringing one unit of charge from one point to another point? Or what is the electric potential?
Uh, elect- uh, Sir, sir, you're asking the definition
Yes,
of electric
electric
current.
potential, right?
It is the rate of flow of charge. It is the rate of
Electric potential.
electric potential.
Yes. So you are not doing revision, right? This was the first definition we learned, right?
Yes,
Amount of work needed to move a unit charge from a reference point to a specific point against the electric field. Got the point?
yes, sir.
So do revision, memorize the definitions. Okay. So what is work done? Potential difference. So this definition, this is elaborated mathematically like this. Potential difference, that is work done in bringing work done. Work done is W, that is potential difference V between two terminal and amount of charge. This is the mathematical definition of this electric potential, where this is electric potential, this is charge, and the amount of work done in bringing positive charge from a given point to another point, the point of reference to the given points. Clear?
Yes, sir.
What is potential difference?
It is the work done to move. It is the work done to move a unit charge from one point to the another point.
It is not the work done. Work done in moving a unit charge from a given reference point to another reference point. Okay.
Yes.
If we will carry 1 gram of, 1 kg of sugar bag from shop to home, we have to do some work, right?
Yes, sir.
The same, if we wanna carry 1 unit of charge from shop to your home, you have to do some work, and that's being called the electric potential. Now it's clear?
Yes, sir.
Okay. So I think we will be stopping class for the day. Still, we have 7 minutes, so I do have to ask some questions. I won't let you go. I won't let you go. I will ask from NCERT only. So did you study the light chapter? Light ray diagram?
Yes, sir.
Okay, who? From me?
Yes, sir.
Okay, from me, then it's good.
So from you and one more teacher is.
Okay. So let me see what to ask further, because we have to utilize the time. Na? Why to leave you 5 or 10 minutes before what you will do? It's tough to find the space. Tough to find the space. Tough to find the space. Okay, no worry. So give me the answer for the question number 1. It's just fresh. Give me the answer for the question number 1.
The resistance of the conductor depends on area of cross section,
Yes.
length,
Yes.
and the
Make it. Yeah.
the conductor.
Clear. Okay. It's not yet more clear. Resistance depends directly on the length of the conductor.
The distance is
And
directly proportional to the length of the conductor.
no,
And
no,
it-
you correct the statement. Resistance is directly proportional to the length and inversely proportional to the area of cross section, right?
Yes, sir.
This is the correct statement. Good.
Okay, sir.
Okay, what about the second question before we end? Clear? Question is clear to you?
Yes, sir.
The current flow more easily through a thick wire or a thin wire of the same material when connected to the same source.
The thing is the thick
R,
wire.
R is inversely proportional to A, right?
Yes, sir.
I'm just writing it with 3 equal signs. So if it is thin, that